Garpenberg is a very exceptional site because it is extremely important that the productivity is high always, but they are also so willing to take the next step in the technology and innovation. And those two combined, that is what makes Garpenberg so special.
It's a quite complex project to do with automation. Typically you'd like to go with automation, like to go from a fixed point A to a fixed point B. Here we load in the quarry, so that's dynamic because we consume the material, there are new blasts, so we have to constantly adapt to that.
Before deployment to a new site like Garpenberg, we carry out a thorough assessment, define the operational setup and prepare the site infrastructure needed for autonomous operation. We look at opportunity from three connected perspectives: technical, operational and commercial. Technically, we assess what is needed for the system to function safely and reliably. Operationally, we look at how the solution will work in practice and how flows can be optimized. Commercially, we define how the solution should be packaged and delivered based on the customer's production requirements. From there, we move into real-world mapping. It is a critical step to set up the autonomous route, and if loading and unloading is dynamic, like in the Garpenberg project, the map needs to reflect real conditions and be updated in real time to match the site's needs.
So, behind setting up a new site is some pre-work. We would designate a spot. This is the general area, a geofenced area, where we can drive the truck. We would also create new LiDAR maps, so that is for NDT navigation. Basically, it's a reference between what the physical sensors on the vehicle see and what we have in the environment. We would also set up low-speed zoning to also set up different vehicles that would be connected to it and also connect our high-integrity safety system to the site control system. We connect all of our vehicles, all of our support vehicles, and then we would also do some site-specific configurations. We start the validation work in our software environments, where we start some virtual testing. That moves on to our test track facilities, where we would run the same software over and over again to gain stability records, understand if we have any issues with the software. And then the software is then propagated to the customer site, and we do some final checks here, particularly when we do specific things, like removal of safety driver. That comes with a set of validation tests that we will perform. And we do that in controlled manners.
Then we go into operational phase, and that's where we start to move material for real. That's the full operation. It's not a test period. That's where we actually make things happen. Readiness to go live is based on a combination of successful verification and validation activities, operational performance and safety performance, and of course the customer readiness. The safety case is progressively matured throughout the deployment and is considered closed once agreed on the operational scope. Risks, mitigations and acceptance criteria have been verified and approved together with the customer and relevant stakeholders.
It's really important to have a good service and repair setup, and the Volvo dealer network is it's a very valuable asset also for us that's doing this autonomous transport.
We do all the service and maintenance on the trucks and the trailers, so they are running for the weeks for the guys up here. They change oils in the engines, fuel filters, and greasing the fifth wheel, so they unhatch the trailer every time they're up here, and then go through the trailer, suspension parts and everything to see that everything is okay.
We work with uptime through a combination of robust product development, data-driven monitoring and preventive maintenance strategies. For the customer, uptime is not only about machine availability, it is about securing production targets, reducing operational disturbances, improving safety and enabling better planning of site operations.